Hey everybody, this is TD Superheroes. My name is Alejandro Perez. I am your sidekick. And in this video, we are going to be going over how to create pull vector controls. They're going to be controlling a pull vector constraint that is attached to a IK handle that is going to basically, like if you had a arm, you're going to be able to aim the elbow using that control. And this is part of a set of tutorials that I'm creating that is to create an auto rig setup. So if you're interested in seeing the other videos in this tutorial, I'll guide you to the iCard over here. That is going to be the playlist for all of these videos. But other than that, let's get started with the tutorial. Okay, so looking at the tool that we have so far, we can create a proxy rig, be able to mirror it from one side to the other, create a skeleton based off of that proxy rig, and then we start creating controls. I actually did modify 2 lines. This was 0 and this was false, but it does the same thing, just turns the visibility off. So this would be the exact state that we left it off, so we can't see those controls. I did turn them back on just to make it a little bit easier. So if we take that line here and this line here and make them ones or true, then we can just see everything that we're working with. And later on we can change back to 0 if we'd like, and really we can put these kind of together. Here, what we can do is make them false, but what we'll do is comment them out for now, and then we'll bring them back whenever we need it later. Okay, so now that we have that, we have to create the pull vector constraints and a control for that. So I think what would be kind of good to do is let's create another function for create pull vector. Okay, and then we will be calling this up here for each one of the arms. And let's say we have a few arguments. So basically the way we're going to need to do it is we're going to do a locator. If we create a locator, then we are going to be able to, actually let's just open up the IKs, that'll be easier. So 1, 2, 3, then click on the locator. We're going to go to constraint, point, and you can see that it snaps into the right position. The axis is still wrong. Then what we end up doing is deleting that, but we can select the locator here, or actually the elbow, then the locator. And then what we're going to do is constrain aim, and we're going to name aim across the X. And let's say the up vector is Y. Okay, so that creates this here. We can delete the locator again, and then basically we just move the locator back up here. And now we have something that is lined up on the exact plane so that we don't get any shifting of the joints once we create the pull vector. So we're going to create that function so that way we don't need to do it over and over again. And basically it'll be target object to be constrained, and we do constrain pull vector, and then now we get that elbow movement. And if we look at it closely, they're completely overlapping. They're not shifted in any way. Okay, so all that being said, we're going to need the name that we want to assign to this locator. So let's say name, and then JNT1, JNT2, and JNT3. And then let's say IK for the IK handle. So those are the arguments that we're going to need. So we'll create the left arm first. So for the name, it's going to be L underscore elbow underscore PV for pull vector underscore CTRL. Then joint 1 is going to be the shoulder for the IK chain. And we can put that as a string. Then we need the elbow. Then we need the wrists. Okay, and then the IK handle that we're going to need is this one right here. So I just push F on the outliner here, and I can copy that. And that's going to be a string as well. Okay, I'm going to save the script and continue on. Okay, so we have all those arguments that we're going to need for our function to work. Now let's go ahead and start creating the function. So we need to create a space locator, and we're going to use n, or let's call this new name. That way it's not a flag. So n equals new, actually not new name, let's call it lock name. Lock for locator name. Okay, so if we run this right now, we shouldn't have any issue, and we got a locator over here, and it is called exactly what we wanted right now. Okay, so we have that. Then we're going to say mc.parent constraint. It could be parent, but it doesn't have to be. Point is just as good for a point constraint. Then we're going to select the targets followed by the object to be constrained. So it's going to be JNT1, JNT2, JNT3. Then we are going to have the lock name be the object to be constrained, and we're going to say maintain offsets is equal to false. Okay, so if we run this now, we should have the locator over here right in the elbow. We need to do the aim constraint next, but we can delete this constraint here. So what I can do is PC, so point constraint, we're creating that as a variable, and then just say mc.delete PC, because we don't need it anymore. We positioned the object right where we need it. Then we can say mc dot, and we'll do the same thing. Let's do aim constraint, since we know we're going to need to delete that as well. Mc dot aim constraint. There we go. And then the target is going to be joint 2, JNT2. Then we are going to have the lock name be the object that is being aimed at. And then we're going to say aim is equal to 1, 0, 0. So that way it's aiming on the x-axis. Okay. And then we'll just say mc.delete aim. Okay, so testing this out again, we can see that this is now oriented correctly, and we can move it in the axis to keep it on the plane, the correct plane. Okay, so now what we can do is move the object. So it's going to be mc.move. We're going to move in object space, so os equals true. And we're going to move it along the x, let's say 2 units. There we go. So now it's positioned right behind it. That is great. Now we just need to have the aim constraint, mc dot, or not aim constraint, sorry, pull vector constraint. And then the target is going to be lock name. And the object to be constrained is going to be IK. And if we go through and run this now, we'll see that we get that movement with the elbow. And the cool thing of this now is, let's say we run this again, create proxy rig. Let's say we kind of adjusted it. Let's say the elbow for some reason was kind of like that. So it's in a completely different plane, but we can create, oops, haha. Let's do it one more time. I adjusted the rig. Let's say I bring it down, so that changes the plane. Then we just need to create the rig, then create the control rig, and you can see that it is aimed down here, which is a different axis. Maybe 1 is too much, 2 for pushing it on the X. Maybe we can just do 1 instead. Let's see. Create proxy rig. Let's test this. We'll move it down. And then create that. So that is being, I don't know how much it moved. It has to be 1. Oops, let's save that. Open up this again. Okay, let me pause this until it comes back up. Okay, so I got it up and running again. I'm going to make a little bit of adjustments on the positioning. So instead of x equals 1, I'm just going to say true, which is what we want. And then I'm going to put a value here. So let's say 3 units. Then I want to make sure that it is relatives equal true. And we want to move in world space coordinate units. And we're going to say that is true. And then now, if we create the proxy rig, create the skeleton, and then create the controls, we get that position there. And if we run this again, oops, that's going to be exactly the same. But I wanted to adjust the locator here so that's different. And you can see that it is positioned appropriately for that position there. In here, you can do 3, maybe 4 for the scale that I'm at right now. That still seems reasonable. So I'll keep it at 4 units away. That way it gives you some wiggle room if there's some weird shape here. Okay, another thing that I would like on this is to have a 0 offset group, just like we have with these things here. So let's create that. We are up here. So when we create the space locator here, we can run the 0 offset that we have up here. Create control, create 0 group. And then we're going to say lock name. So that creates the 0 group, but we want to make sure that now instead of the locator, we're actually moving to 0. So let's create a variable. We'll call it 0. And then we're going to actually replace lock name with 0 on all of these things throughout the script. Oh, actually, that last one is still on the locator because we want the locator itself to be the object that's constrained. Let's make sure that this works the way we want it. It looks like it does. Yep. Okay, so we have this set up for the elbow. Now let's just go ahead and expand that for the other arm and the legs. So here, this is going to be basically the same thing, but R for the right side, Okay, so we can test this really quick. Now we have a control for each side. That is great. Okay, now let's copy this line, go paste it here. I'm gonna change the items to be for the legs as knee. Then we have shoulder, or sorry, not shoulder, but hip, knee, ankle, and leg. Hopefully I got all those names right and we don't get an error here. Doesn't look like we have an error. Let's double check here. Looks like we have a control right where it should be and we're able to move it. That is great. So let's go ahead and copy that line and we're gonna paste it here. We're gonna do the right side. So R, 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 and R. Create proxy rig, create skeleton from proxy rig, create control rig. I did see an error there for a moment, so let me check I've cleared out everything here. Make sure that I'm not getting an error, or if we are, that we can fix it so we don't have an error. That's good. So we can move these controls around. We can see that we're moving all of the IKs with its pull vectors. That is great. Okay, so let's clean this up a little bit. We are going to make sure that these controls are parented to the control group, which is called CTRLS. So we're going to say mc.parent, and we have the names here. Oops. Parent. And then this one's going to be R. Then we're going to get the knee. And this one's going to be R. And then we need the last item to be CTRLS. There we go. We have that as controls. And let's test it here. So we have the controls. Oh, we did parent the correct controls, but they are left outside here. So we can fix that. Let's look at the code here. Let's remove this line here for the parenting. And what we'll do is in the create pull vectors here, we'll say mc.parent 0 to CTRLS. So if we go through it and do that now, our outliner should look right. There we go. That is a nice looking set of pull vectors. Okay, I hope you guys got through that okay. So that is how we create the pull vector controls. I hope you found it useful. If you did, you might find this video useful. The YouTube algorithm decided it was just right for you.